it's me, Minnie, and today I'm going to show you how to calculate molar mass. In the previous video, I showed how to calculate molar mass. In this video, I'm going to show you how to calculate molar mass, but there will be parentheses involved. Please remember to subscribe to our channel, and now let's get started. So I believe that this is calcium hydroxide. We have CaOH in parentheses and a subscript of 2 on the outside. So I think that if I show you how to find the molar mass of calcium hydroxide, you'll be able to find the molar masses of other things that have parentheses involved. So let's go ahead and find the molar mass of calcium hydroxide. So the first thing that I'm going to do is just take a portion of this. We're just going to look at calcium here, which is Ca. So I've already found calcium on the periodic table. On the right side of the screen, you'll be able to see that its atomic number is 20 and its atomic mass is 40.08. Just note that atomic masses may be different on different periodic tables. So we're going to take 40.08, which is the atomic mass for calcium, and we're going to multiply that by 1, which is the subscript for calcium. Even though there is no apparent subscript attached to calcium, we can assume that it is 1. So far we have 40.08 times 1 in parentheses, and we have more to do, which is why I put that ellipsis there. Now let's move on to the next element. We have O. We have O, which is for oxygen, and let's find that on the periodic table. I've already found it. If you look on the right side of the screen, you'll see that oxygen's atomic number is 8 and its atomic mass is 16. Now let's look at the subscript for oxygen. So the subscript for oxygen inside of the parentheses is 1. However, there is a 2 outside of the parentheses. That 2 will affect the oxygen. It's like distribution. So the 2 will be distributed to the oxygen. So we're going to multiply those 2 subscripts together, 2 times 1, or 1 times 2. And that equals 2. So there are 2 oxygens, okay? So now we're going to take that 2 and we're going to multiply it by 16. So now we have 16.00 times 2 in parentheses. So overall we have 40.08 times 1 in parentheses plus 16.00 times 2 in parentheses. And we still have more to do. Now let's move on to H, which is hydrogen. Okay, so we have hydrogen. Let's look for that on the periodic table. I've already found it. If you look on the right side of the screen, you'll see that the atomic number of hydrogen is 1 and its atomic mass is 1.01. So let's look at the subscript for hydrogen inside of the parentheses. The subscript for hydrogen inside of the parentheses is 1. But on the outside, there's a 2. Just like with the oxygen, this 2 is going to affect the hydrogen as well, so it's going to be distributed to the hydrogen. So we're going to multiply the 2 numbers of 1 and 2 together. Remember, those are the subscripts, and that equals 2. So we're going to use that number of 2, and we're going to multiply it by 1.01, which is the atomic mass. So now we have 1.01 times 2 in parentheses. Overall, we have 40.08 times 1 in parentheses plus 16.00 times 2 in parentheses plus 1.01 times 2 in parentheses. If we calculate that, we'll be able to get the molar mass. So overall, we have 40.08 times 1 in parentheses plus 16.00 times 2 in parentheses plus 1.01 times 2 in parentheses, and that equals 74.1 grams per mole. And that is the molar mass for calcium hydroxide. By the way, you might have gotten something a little bit different if you use different atomic mass numbers. I hope you understood how we found the molar mass. This one might have been a little bit tricky because there were parentheses involved. Maybe not. If you want, you can look at a previous video on finding molar mass. I hope you enjoyed this video. I hope you learned from this video, and please subscribe to our channel.